This example shows how to simplify an algebraic expression containing radicals. Note that I've mentioned that you can simplify each expression before you try to add and subtract. Each example will be a little bit different, of course. Here I notice that both of these radicals contain x to the power of 3. So there are a couple of different ways you could do this question. I'm going to pursue it by simplifying both first. So I'm just going to take a minute to break down the square root of 18. So I'm going to call that 9 times 2 using my largest perfect square. And I know the square root of 9, of course, is 3. So this is 3 root 2. 8 I know is 4 times 2. So I know the square root of 4 is 2 root 2. So let's go back and replace those radicals with the mixed radicals we have here now. So when I look at 18, I'm going to replace that with 3 square root 2. Now, underneath my square root sign, I still have x to the power of 3. Because it's an odd exponent, I am going to rewrite it as x to the power 2 with an x left over. Now, in the next one, I already have a 2 as a coefficient outside, so I'm just going to leave that where it is, and I'm going to use brackets. The square root of 8 we just mentioned was 2 square root 2. So I'm going to, again, rewrite x to the power 3 as x squared root x. Now, I'm going to kind of tidy this up a little bit. Right here I have an even exponent. So the square root of an even exponent, we learned, is going to be half the exponent. So I'm going to bring that outside my square root sign. And right here now, left underneath my square root sign will be 2x. The same idea will happen over here. So 2 times 2 gets multiplied. I'm going to call that 4. Here's my even exponent, x to the power 2. So that's going to come outside and be x. And underneath my square root sign, I still have a 2 and an x. Now, if you look at what we have here, we have like radicals. The coefficients both have a variable of x. The radicand for both is 2x. So I can now add these and I will get 7x square root 2x.